Hello and welcome. In this video we will discuss position, distance and displacement. The first step in describing motion of a particle is to set up a coordinate system. Set up a coordinate system. This is nothing but choosing x-axis with origin at x equals to 0. The arrow indicates this is positive x-axis, and I choose the origin to be at x equals to 0. So this is the coordinate system. Once you choose the coordinate system, you must be consistent with it throughout the calculations that follow. Now, if the initial position of the particle is denoted by xi and the final position of the particle, which is traveling in this direction on the positive x-axis, is denoted by xf, we can clearly see that xf, the final position, is greater than the initial position xi, because we chose the positive x-axis as the direction of motion of this particle. Distance is the total length of travel. Distance is the total length of travel, which means it is the total distance you travel. For example, you travel from here to this point, which is separated by, say for example, 4 meters, and you're traveling in positive x-axis, the direction of positive x-axis. You have traveled from here to here, and you travel back. The total distance covered would be 4 meters up and 4 meters down. Therefore, the total distance you traveled is 8 meters. And the units that are used to measure the distance are meters in MKS system. Now, displacement, on the other hand, is the change in position. Displacement is change in position. For example, let xi be your initial position and xf the final position. Then the displacement is the change in position, which is xf minus xi. This is denoted by delta x. Delta x is the notation that we use to indicate change in position, displacement. And now displacement also has the same units as the distance, which is meters in MKS system. But distance and displacement are two different terms. They are not the same. Now consider the following, this diagram here, where you have school at x equals to 0, that is the origin, and your house, which is 2 meters from the school, and there is a store that is 4 meters from your house. All these are in the positive x-axis. Now if you travel from your house to the store and back, the distance traveled is the total length of travel, which is 4 meters plus 4 meters, 8 meters. Now let us see what the displacement is for this figure. Now your final position minus initial position is the change in displacement. Now if you have started here, which is your initial position, and you came back to this position, which is your final position, that is 2 meters minus 2 meters. The displacement in this case is 0, whereas the distance is 8 meters, which clearly shows that distance and displacement are two different terms. Now displacement either can be positive or negative or 0, whereas distance is always positive.